Today we are learning 10.5 sine and cosine ratios. Now again, these were brought up last Thursday when we were learning about tangent, because tangent, sine, and cosine all together are known as trigonometric ratios. So today, as a little note, tangent here, use the opposite and adjacent leg. Cosine and sine are going to use a combination of adjacent hypotenuse or opposite and hypotenuse. So coming down here, sine and cosine ratios. For any acute angle A of a right triangle, sine of A equals opposite over hypotenuse. Cosine of A equals adjacent over hypotenuse. And last week I referenced SOHCAHTOA. And here's where it comes from. Sine equals op over height. Cosine equals adjacent over height for hypotenuse. And tangent, which we already learned, is OA, opposite over adjacent. Right? And so where does SOHCAHTOA come from? Again, kind of in yellow. The S-O-H, so, ka, C-A-H, TOA, T-O-A. The first letter and the pieces that they belong to. So it is very critical that you are able to identify, if I gave you angle A, which is opposite, which is adjacent, and which is hypotenuse. As a note, the right angle always points to your hypotenuse. So then all that's left is adjacent and opposite. Opposite is not going to use the two sides that make the angle. So the two sides that make angle A or B are always going to be adjacent hypotenuse. What's opposite of angle A is this green side. So that leg is going to be our opposite. Majority of this lesson, we are going to be focused on these two. Sine equals opposite over hypotenuse, and cosine equals adjacent over hypotenuse. Starting off, find sine of A and cosine of A. So again, sine of A equals opposite over hypotenuse. So, OH, and that's SOA, so, that's OH. So, going to angle A, we've got the right angle first, here's our hypotenuse. Angle A is made by these two sides, so this side is going to be our opposite. 15s are opposite, 8s are adjacent. So, opposite over adjacent is opposite was 15, sorry, not over adjacent, over hypotenuse. So we got 15 over, and the hypotenuse was 17. And this is our sine of A. 15 over 17. Now, why did I find adjacent as well? Cosine of A is also what they asked for, and that's adjacent over hypotenuse. And again, I won't write this every slide, but I will start to write ha. So we're looking for adjacent hypotenuse. So adjacent, we have 8 is the numerator. Hypotenuse stays the same, 17. And so the only difference between sine and cosine is our numerator, right? You both have 17 here. The hypotenuse is the same. The numerators are what? Are different. The next example, again dealing with sine of A. We're going to cosine of A in red, sine in blue is opposite over hypotenuse. And that's how I'm going to label it, the angle, so the sides. 25 is hypotenuse. And now for A, this is our angle. 7 is right next to us, right? The legs that use that side are A and H. And this one must be opposite. So we've got 24 for opposite, 25 for hypotenuse, and 24 25th is our sine. Cosine, again, A over H. And we already have it labeled. We have 7 over 25. And so when we're doing the same angle, it's pretty quick. It's the other side over the hypotenuse. Okay, so pretty straightforward. And make sure you write down all the notes from this slide, and we will continue to do similarly. Next, we've got to find sine of A and cosine of A. One more step. So again, I think I'm on red, so cosine of A, sine of A, and we've got A is here, hypotenuse Opposite of our right angle, not to get you confused, but it's always where the right angle pointing. Angle A uses sides 6 and 10, so 6 has to be adjacent, 8 therefore is our opposite. So sine is opposite over hypotenuse, and we got 8, 10. Now this is not simplified. Divide by 2, and we get 4 fifths. Cosine, adjacent over hypotenuse, so they're already labeled 6 and 10, so 6 over 10, also not simplified, gives us 3 fifths. Okay, so, moving on, find sine and cosine, write your answer this fraction in decimals, starting with 4 decimal places. This came from the book in terms of direction. The focus here, even on the homework, is I just want you to focus on fractions. We can simplify the fraction, that's all we're going for. If they look a little ugly, that's okay. So, moving this to a different color, sine of A is so, opposite over hypotenuse. So here's A, hypotenuse is 41. It should always be the largest number as your guide. The two sides that are made to form angle A are going to be that angle are going to be adjacent and hypotenuse. So that means 40 is our opposite. And so opposite is 40, hypotenuse 41. 40, 41. Cosine of A uses adjacent and hypotenuse. And again, cosine, ca, it's always A over H. But it's not, these two A's are not related. Okay? So adjacent is 9. Hypotenuse is, again, the same as our first one, 41. Next example, we have some square roots. And so, again, finding A, the largest number is 2. There's the hypotenuse. A is created by these two sides, so this one got to be adjacent, and opposite is the one further away. So sine of A, opposite over hypotenuse. And we've got then labeled already is square root of 2 and 2. Or something like that, square root of 2 over 2. Cosine of A equals adjacent over hypotenuse, and that is square root of 2 over 2. They're going to match when we are in that 45, 45, 90 triangle. You have to recognize the side and the hypotenuse. Another set with a square root. Again, sine of A, opposite over hypotenuse. And then we need a label. Where's our A? Here's A. 8's our largest number. Square root of 39 is a little more than 6. That's another way to know that 8's our largest number. 5 uses the side that make angle A, so that's adjacent. 39 is on our opposite. Square root of 39. Okay. So square root of 39 over 8 is opposite over hypotenuse. Cosine of A equals adjacent over hypotenuse. We already know hypotenuse is 8. The side we haven't used yet is 5. And there are our answers. And again, we're not rounding 4 decimal places. That is more of calculator practice than we currently need. Moving on. Now, here's a real calculator practice. Use the calculator to approximate the value to 4 decimal places. Now, 4 decimal places is fine in this because they are almost always decimal less than 0 if we are in the right mode. So sine of 72 degrees. We get our calculator out. We hit the sine button. 72 parentheses. Now, no matter what calculator in, you want to double check that degree is there. I see degree kind of right here under my cursor on the right. Even on lower, more basic calculators, they may say D or DEG to symbolize that they're in degrees. It's a standard form they should be in. Sine of 72, pardon me, is 0.95105, so that will round up to 0.9511. Sine of 43 and sine of 15, we'll type in short here. 68199. So as a reminder, with this 68199 for our rounding, we only need 4, so this is what we're looking. Since this rounds up, it doesn't round up to 10, our 19 rounds up to 20, So again, just to show the appropriate way, you do need to round up the next 2 decimals because 19 rounds to 20, and you still need that 0 because it wasn't exact, because it rounded. Okay. Lastly, sine of 15, 2, 5, 8, 8, all after the decimal point, and no rounding necessary for that. Okay, whereas next, we'll probably move on to cosine. Cosine of 0, cosine of 43, and cosine of 75. Usually your sine button is right next to your cosine button. So cosine again of 0 equals 1. Now we don't typically run into a 0-degree angle, so you won't see that, but that's more of just letting you know cosine values and sine values will be between -1 and 1, and in triangles is between 0 and 1. You won't have any negative angles. Cosine of 43 is 0.71313. And this 5 will round our other 3 up to 4. And one last one, cosine of 75. 2588 as well. So 73 will 14. 2588. And I usually put a 0 in front so that that decimal point doesn't get eaten up. And the 1, we don't need 4 zeros because it wasn't rounded to that. It was exact. Lastly, how we can use sine and cosine. So last week we focused on tangents. In this case, tangent wouldn't help us, right? We've got hypotenuse and an angle. We can't solve because tangent uses opposite and adjacent of that. But with sine and cosine, they use hypotenuse. So in this case, what would sine of 34 degrees be? Right? Sine of 34 degrees would be opposite over hypotenuse. So that would give us a over 7, and we can solve. Now, as a reminder, when we did this with tangent, I put sine of 34 degrees over 1, so we could use our cross multiplying and dividing with proportion to solve. So 1a equals 7 times sine of 34 degrees. And we'll find out what that is to the nearest tenth in a moment. But we also need to solve for b. Now b will use cosine. Why? Because we already have hypotenuse. We don't want to use a because it will be a rounded value. So we want to use our exact value. And we're going to then use the 34 degrees. We're going to use b and our hypotenuse, which is 7. So cosine of 34 degrees. And again, we already know it's going to be over 1 again. So we'll write that over 1 equals, in this case, b over 7. Looks very similar to the last one, but the difference is cosine. Cosine will get us a different value. Cross multiply, we have b equals 7 cosine of 34. And now we're going to plug those in. 7 sine of 34, 3.91. 7 cosine of 34, 5.8. So 3.9 and 5.8 are our answers. We almost solved the whole triangle there. The only part we're missing is this angle up here. We want to call it angle B for a second. We could still solve for that because we have 2 out of the 3 angles in the triangle. So kind of to foreshadow what we're going to get into for the last lesson of the chapter is going to focus on solving for the rest of the triangle. Next part, same situation. We've got hypotenuse, so it's opposite of this right angle. We've got an angle. We're going to use our sine of that angle and our cosine of that angle to solve. So sine over 1 equals opposite over hypotenuse, or a over 10. Cross multiply. A sometimes look like 9. And we get a equals 10 sine of 32. And then again, the same idea would be cosine of 32. Because B is adjacent. So adjacent over hypotenuse. Right. You need to have SOHCAHTOA written somewhere as a reminder. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent, and that's where SOHCAHTOA comes in. Right? If you need that, that is fine to write on your paper. It's actually a fairly common thing to do. Cross multiply, we get b times 1, so b equals 10 times cosine of 32. And again, we're rounding to the nearest 10. So 10 sine of 32 will get us one answer. 5.29, so it's going to round to 5.3. And then 10 cosine of 32. So 5.3 and 8.48. This 8 is going to cause the 4 to round up. So 5.3 and 8.5. One more set of problems. Now they switch where our angle is. So again, if this is our angle A, what's next to it, and you maybe not use black for writing on black. That forms those angles. We've got hypotenuse, and little b is capital A for adjacent. Opposite is our A. So again, sine of 65 over 1 equals A with its opposite over 12 hypotenuse. Cross multiply and divide to solve. A equals 12 sine of 65. And then cosine of 65, the same idea. Also over 1 equals B, because it's adjacent, over hypotenuse of 12. And then cross multiply and divide to get B equals 12 cosine of 65 degrees. And then we'll plug that into our calculator. So this time, our first one's larger. Sine of 65 is 10.87, so that's going to round up to 10.9. 5.07 is going to round up to 5.1. So 10.9 and 5.1 are going to be our answers. Okay, and if they had a label for like inches or centimeters, we would also use that as well. The last one here, again, from 43 degrees, we have 5 as our hypotenuse, again, opposite here. 43 degrees is created by B and H, which means B is our adjacent, A must be opposite. So sine of 43 degrees over 1 equals A, by the way, over 5. And again, the same idea, cosine of the same angle, going to be B over 5. Solving. 5 sine equals 1/8, so A equals 5 sine 43 degrees. And B equals 5 cosine of 43. Coming in, 5 sine of 43, 3.4, 5 cosine of 43, 3.7. 3.4 and 3.7 are our final answers. And that will wrap up this lesson. Homework should be on the board.